Doubts are there, huh? ठीक है बेटा. Let me open up the presentation and one by one we will go into doubts. Just give me a minute. I'll open up the presentation. Okay, beta. Can you tell me your doubts, beta, one by one?
सर क्वेश्चन नंबर 1 में टाइम वाला एक बार फटाफट बता दो सर, भूल गए.
Okay, ETA calculation, right?
यस सर.
ओके, ठीक है बेटा. ये तो मैं आपको ऐसे ही बता देता हूँ. Now beta, whenever you calculate the ETA, usually the departure time will be given to you as the local time of the port from where you are departing, and the ETA is always calculated as per the local time of the place where you are going, because you need to pass on your ETA. So it has to be as per the local time of the arrival port or your destination. So what is to be done here is, now departure time is given to you as local time. You convert it into GMT. Okay, I'll explain to you how we will do this in our question. So first you understand the concept. Convert the departure time into GMT. Then you will be able to calculate the voyage duration. Voyage duration is calculated by dividing the distance with the speed of the ship. So you add this voyage duration to the GMT of departure. So once you add the voyage duration to GMT departure, you will get GMT arrival. Once you get GMT of arrival, convert that into local time of your arrival port. So let me show this to you now.
डिस्टेंस कौन सा लेगा?
अभी बता रहा हूँ बेटा, just 1 minute. Let's open up the whiteboard. Okay, so you see beta, the departure time which is given to us in the question, 1500 hours on the 10th of June. So this is the departure time, 1500 hours on the 10th of June. So let's note it down. So 10th of June, that is the 10th day, and the time is 1500 hours. So 15 hours and 00 minutes. Now this is the departure time, and they have given us the zone is -9.5. Now when you look at this zone, sometimes they give you zone, sometimes they give you zone time. Don't bother about what is the meaning of the minus or what is the meaning of the plus. This could be confusing. What you do is you just check out the longitude of your starting position. In this case, the longitude is 147.20 east. Now, once you know the longitude, we know longitude east, GMT least. So GMT has to be lesser. So for GMT to be lesser, this difference of 9.5 hours obviously has to be subtracted. So I'm going to subtract this 9 hours and 30 minutes. So when you do that, you get the time 10:05 hours and 30 minutes. This is your GMT departure. Up to here, okay, beta?
Yes, sir.
Very good. Now what we do is,
सर
बोलो बेटा.
सर जैसे मैंने चार्ट वर्क के क्वेश्चन पढ़ा था उसमें तो जैसे जब LIT दिया हुआ होता है ईस्ट होता है और अपने पास जो टाइम दिया होता है उसको माइनस करते हैं तो हम GMT पे डायरेक्टली पहुंच जाते हैं पर इसमें अगर हम LIT को डिवाइड करते हैं 14720 को अगर डिवाइड करते हैं इस पोजीशन को तो वी विल बी रीचिंग 5:10 नॉट 30.
बेटा इस क्वेश्चन में उन्होंने आपको LMT नहीं दिया है, उन्होंने आपको पोर्ट का लोकल टाइम दिया है. They have not given you LMT. LMT is used in the sea. When you are at a port, either departing or arriving, you use the local time of that place, isn't it?
Okay.
So whenever in these questions they tell you the time, it will be the time maintained by that particular port. अगर starting position है तो जो उस port में time maintain हो रहा है, the departure time will be as per that, and the ETA will be as per the time being maintained at your destination.
ठीक है सर.
Okay. Okay. So that's why we have used the 9.5 hour difference and we have not divided 147 by 15. So we don't need the LIT here. Okay. So we have got the GMT of departure. Now in this question, the master is following the weather advisory. That means he is doing composite sailing. The master wishes to do the Great Circle track, but the weather report said that you should not go more than 50 to 43 degree latitude. So he has followed the weather advisory. That means he's done composite sailing. So your total composite distance is 5323.4. Right, beta? Up to here, okay?
Yes, sir.
Now the speed of the ship is 14 knots. So can you tell me, beta, how many days, hours, and minutes is the vessel going to take for the voyage? We have the distance, we have the
15
speed.
15 days, 20 hours, 14 minutes.
Okay, so that comes to 15 days, 20 hours, and 4040 or 14, beta?
14, sir.
14. So this is our voyage duration. So let's write it here. This is our voyage duration. Excuse my handwriting, that's with a mouse. So I'm going to just add this voyage duration to the GMT of departure. So this gives me 44 minutes, 01 hours, and 26th day. So अब बेटा ये जो time आ गया मेरे पास, what is this time?
GMT arrival.
Very good. This time is the GMT arrival. So if we follow this 14 knots of speed and this distance 5323.4, we should be arriving at our destination on 26th of June at 0144 hours GMT. Now we need to give the ETA in local time. So let's see now. He is given the arrival port zone time is +5. So as I told you, forget about this plus and minus sign. This could be confusing. So you pick up this 5 hours. So the difference is 5 hours. Let me write it here. We have the difference as 5 hours. Now let me check the longitude of my arrival port. The longitude is 072 43 minute west. Now longitude west, GMT best. So GMT has to be best. That means LMT has to be lesser. So, or the local time has to be lesser. So that is possible when I subtract this 5 hours from the GMT. So once I do that, it gives me 44. Then we have 20, and the day comes to 25th day. So 25th day, 20 hours and 44 minutes. That is the arrival time as per the local time of my arrival port. So the answer which we have here is 25 day, 20 hours, 45 minute. So this 1 minute could be because of rounding off somewhere. So that's fine. So this is the answer for our ETA beta.
Sir, sir,
बोलो बेटा बोलो.
हाँ जी सर, ये क्लियर है सर. सर मैं वैसे जानना चाहता था सिर्फ, जैसे सर अभी ये इसमें लिखा हुआ है जोन, दैट इज रिटन -9.5 और इट इज जस्ट 9.5 सर.
ओके
सर
बेटा.
जैसे अभी मतलब
हाँ.
मेरा कहने का मतलब सर, जैसे दो चीजें होती हैं, एक टाइम जोन होता है और एक जोन टाइम होता है, दोनों
राइट
ऑपोजिट लिखे जाते हैं. अब
राइट.
सर इसमें जैसे लिखा है जोन 9.5 -9.5, सर इसका मतलब क्या यही हुआ ना कि मैं जहाँ पे खड़ा हूँ, अगर मैं इस टाइम से 9.5 घंटे माइनस कर दूंगा तो मैं जीएमटी पे पहुंच जाऊंगा, राइट?
दैट्स करेक्ट बेटा.
ओके सर. सर ऐसे करके मैं जीएमटी पे पहुंच गया. अब सर
राइट.
दूसरी जगह लिखा है जोन टाइम +5. सर इस पार्ट का मतलब बस आप बता दीजिए. जैसे जीएमटी में पहुंच गया मैं 5:30 बजे, अब इसमें लिखा है जोन टाइम +5, तो अगर मतलब मैं उस जगह पे खड़ा होके अपने टाइम में 5 घंटे ऐड कर दूं तो मैं जीएमटी पे पहुंच गया, या मैं ऑलरेडी 5 आवर्स एडेड हूँ
नो नो
विद
नो.
रिस्पेक्ट टू जीएमटी?
You are beta, it is basically you add 5 hours to your time and you will get the GMT.
सर अब जैसे सर ये 5:30 बजे अपना मैं जीएमटी पे पहुंच गया था 26 डे को 01:44 आवर्स पे, राइट सर?
राइट राइट.
अब सर यहाँ पे पहुंच के मैं देखता हूँ कि जो नेक्स्ट अराइवल पोर्ट का है वो है जोन टाइम +5. तो मतलब
राइट.
एक सर जैसे एकदम से आता है ना कि ये जोन टाइम, अब आगे जाने के लिए मुझे +5 ऐड करना है या माइनस करना है?
बेटा आप इसमें ना, जैसे मैंने आपको बताया, डोंट गो बाय
नहीं नहीं
द
सर, वो
वर्ड्स.
ये वाला मेथड सर जो आपने बताया ये तो ये तो आता है, मतलब क्वेश्चन सॉल्व करने के लिए इट्स ओके. मैं सर जस्ट नॉलेज के लिए, जैसे हम कर लेते हैं ना सर, ये टाइम जोन तो ऐसे ही कैलकुलेट हो जाता होता है, तो इसलिए पूछ रहा था सर कि लाइक अगर मैं जीएमटी पे पहुंच के भी ये जोन टाइम +5 लिखा हुआ है तो इसमें ये प्लस क्यों नहीं हो रहा, माइनस क्यों हो रहा है, लाइक ऐसे?
ओके मैं आपको ना, ये एक्चुअली टाइम जोन और जोन टाइम दो
हाँ,
टर्म्स
ये
हैं.
दोनों ऑपोजिट होते हैं. हाँ जी, ये एक प्लस होता है तो एक नेगेटिव, जैसे इंडिया +530 है बट जोन टाइम में -530 आता है शायद, राइट
तो
सर?
बेटा होल्ड ऑन, मैं समझ गया तुम्हारी बात. तुम
हाँ.
थोड़ा सा इसको होल्ड करो. लेट मी
ओके.
कंप्लीट द डाउट्स इन दिस असाइनमेंट. एक बार
ठीक है
वो
सर.
कंप्लीट हो जाए फिर मैं तुम्हें ये जोन टाइम और टाइम जोन दोनों बताता हूँ.
ठीक है सर.
ओके.
ओके.
अब
ओके.
अब बेटा ये जो ETA कैलकुलेशन करने का मेथड है जिसमें हमने GMT टू GMT अपना टाइम निकाला है. वी कन्वर्टेड द डिपार्चर टाइम इन GMT, added the voyage duration, and we found the arrival time in GMT, and we converted it into whatever zone time or time zone was required to local time of the destination port. ये हमने convert कर लिया है. अब इस मेथड की जो एडवांटेज है, एडवांटेज ये है that अगर आप ये मेथड फॉलो करते हो You don't have to bother about anything else. By anything else I mean, let us say for example, जैसे इस particular question में are you crossing the 180-degree meridian, international date line?
Yes, sir.
Yes, sir.
Yes, sir.
Right, you are crossing the 180-degree meridian. Now, when you cross 180-degree meridian, as far as the local time is concerned, there is a change in the date. You have to either go one day ahead or one day behind, depending upon in which direction you are moving. So, अगर आप ये method follow करते हो, GMT to GMT, you don't have to bother about any date change. Whether you are crossing the international date line or you are not crossing, nothing has to be done. But if you go into LMT to LMT, which you should never do, अगर आप LMT to LMT ETA निकालने की कोशिश करोगे, then you will have to see whether you are crossing the international date line or not, and you will also have to see what is the direction in which it is being crossed. So it becomes all the more complicated and confusing. So that's why जहां कहीं भी ETA की कैलकुलेशन हो, आंख बंद करके सबसे पहले GMT डिपार्चर निकालो, उसमें अपनी वॉइस ड्यूरेशन को ऐड करो एंड फाइंड आउट द GMT ऑफ अराइवल. ओके बेटा, नोटेड?
सर वो
Yes, sir.
सर
यस
सर
बोलो बेटा.
सर ये जो सेकंड -0500 किया है ये नहीं समझ में आया. जैसे ऊपर वाला तो समझ में आ गया, ईस्ट में था तो आप जैसे 9 पॉइंट LMT मत करो, स्पोर्ट वाला माइनस कर दो, पर ये वेस्ट में था तो ये तो ऐड होना चाहिए था ना.
अभी बताते हैं बेटा. ओके, अब देखो अराइवल पोर्ट पे जब आप पहुंचे तो GMT टाइम है 26 डे 1 आवर 44 मिनट, राइट? हमें लोकल टाइम को फाइंड आउट करना है.
यस सर.
दोनों में डिफरेंस 5 घंटे का है, ये हमें क्वेश्चन में बता दिया गया है. नाउ द कंफ्यूजन इज वेदर वी शुड ऐड इट और सब्ट्रैक्ट इट.
हाँ सर.
तो इसके लिए आपने सीधा अपनी जो डेस्टिनेशन पोजीशन है उसके लॉन्जिट्यूड पे जाना है. व्हाट इज द लॉन्जिट्यूड?
वेस्ट में है 72 वेस्ट.
राइट, सो लॉन्जिट्यूड वेस्ट GMT
बेस्ट.
West.
right. So if longitude west GMT is best, so that means local time has to be lesser than GMT. So if the local time has to be lesser, obviously you will have to subtract the 5 hour difference. Did you get it beta?
यस सर.
बड़ी धीरे धीरे से आवाज आ रही है बेटा. अब भी कोई डाउट है?
सर नहीं आया मेरा तो फिर भी अभी थोड़ा सा.
समझ में नहीं आया बेटा?
सर जैसे ऊपर वाला ईस्ट का था वो सीधा सीधा समझ में आ गया. GMT था ईस्ट में है तो दैट विल बी इन द माइनस बिकॉज द वेसल इज ऑन द ईस्ट ऑफ द GMT. दिस शुड बी एडेड देन व्हाई वी हैज माइनस लाइक इन द वेस्ट. तो ये तो ऐड होना चाहिए था, ये माइनस क्यों हुआ मतलब?
बेटा तुम मुझे बस एक बात बता दो, ये जो ईडीएम है लॉन्जिट्यूड वेस्ट GMT बेस्ट, लॉन्जिट्यूड ईस्ट GMT लीस्ट, डू यू
हाँ.
एग्री विद दिस या हमें
हाँ,
इसकी भी बेस में जाना है?
नहीं नहीं ये ठीक है सर.
ये कंफर्म है ना बेटा? ठीक है ना
हाँ.
ये?
हाँ.
ओके, तो लेट मी राइट इट हियर. लॉन्जिट्यूड वेस्ट GMT बेस्ट, GMT बेस्ट. अब ये जो बेस्ट हम लिखते हैं बेटा, ये किसके कंपैरिजन में बेस्ट होता है GMT?
ऑब्जर्वर के.
नो बेटा, टाइम ऑब्जर्वर के रेस्पेक्ट में कैसे ज्यादा या कम हो
सॉरी.
सकता है?
हाँ हाँ सॉरी, टाइम के वो ग्रीनविच के.
नो, ग्रीनविच मेरिडियन से GMT का क्या लेना देना? मतलब GMT बेस्ट मींस GMT इज बिगर, इट हैज टू बी बिगर देन ए टाइम ना. सो व्हिच टाइम, अदर टाइम दे आर टॉकिंग अबाउट? किससे बिगर है ये?
फिर जैसे इसे अपन सर्किल पे ड्रॉ करते थे, सेंटर को G लेते थे तो ऑब्जर्वर और ऑब्जर्व से आगे आपकी बॉडी आती थी, तब ये कंडीशन सही होती थी. जैसे एक सर्किल ले लिया, उसमें सेंटर में G ले लिया, फिर
बेटा पहले इसको समझ लें, फिर सर्कल पे भी चलते हैं. पहले इसको समझ लेते हैं, फिर सर्कल पे भी चलते हैं। मुझे बस ये बताओ कि लॉन्जिट्यूड वेस्ट, जीएमटी बेस्ट, ये जो बेस्ट है, नाउ जीएमटी इज ए टाइम, इफ इट इज बेस्ट, तो दूसरा कौन सा टाइम है जिसके साथ हम इसे कंपेयर कर रहे हैं?
सर खुद के टाइम से।
दैट मीन्स द लोकल टाइम,
हाँ
राइट? खुद के टाइम को लोकल टाइम बोलते हैं. यू कैन कॉल इट
हाँ
एल एम टी इफ यू आर यूजिंग द
या
लॉन्जिट्यूड, और यू कैन कॉल इट एल टी इफ यू आर यूजिंग द जोन. सो इसका मतलब है longitude west GMT best, that means local time has to be a smaller value than GMT and GMT has to be a greater value, तभी best होगा ना.
हाँ तभी बड़ा होगा। हाँ
तो अब बेटा GMT तो है 26 डे 1 आवर 44 मिनट, लोकल टाइम आपने निकालना है जो इससे कम है. तो इससे कम पे जाने के लिए ये 5 घंटे को माइनस करेंगे या प्लस?
ठीक है सर।
ओके बेटा,
माइनस।
ओके
हाँ ओके सर।
ओके. अब चलते हैं सर्कल पे बेटा. ये लो, ये सर्कल पे भी आ गए. ये मैंने यहाँ पे ग्रीनविच मेरिडियन बना दिया, और वेस्टर्ली लॉन्जिट्यूड है 72 वेस्ट, तो ऑब्जर्वर को भी बना
इस
देते हैं.
तरफ ऑब्जर्वर बना दिया। हाँ
ये मैंने यहाँ पे ऑब्जर्वर भी बना दिया, राइट? अब सन को भी बना दें कहीं पे,
हाँ सर सन ऊपर चला
और
जाएगा ना, लंबा
कहाँ
बड़ा
रखना
है
है
तो
सन
इसलिए
को? बताओ, सन को कहाँ रखना चाहते हो?
180 से
कहीं भी बना दो।
ये 180
कहीं
बना
भी
दिया
बना।
मैंने. सन को ईस्ट में रखना है, वेस्ट में रखना है, कहाँ रखना चाहते हो बताओ? वेयर एवर यू वॉन्ट टू प्लेस.
180 पे रखो।
सन को
ईस्ट पे सर, राइजेस इन द ईस्ट सर.
20 into
ओके, यहाँ पे ईस्ट में रख दें, राइजिंग इन द ईस्ट. ये लो बेटा, ये आ गया सन यहाँ पे. ठीक है बेटा, इसको रिप्रेजेंट कर देते हैं एस के साथ. अब जो टाइम आप मैयर करते हो, ओके, जो टाइम आप मैयर करते हो, वो टाइम क्या होता है?
इसके
सी द
अपोजिट
टाइम.
inferior meridian से
करते हैं।
हाँ,
इंफीरियर मेरिडियन से करते हैं।
राइट, वेरी गुड बेटा. सो जीएमटी अगर आपने मैयर करना है, लेट मी पिक अप जीएमटी इन ग्रीन कलर. लेट्स पिक अप द ग्रीन कलर फॉर जीएमटी. इंफीरियर मेरिडियन ऑफ ग्रीनविच से अप टू द सन, ये जो आर्क देख रहे हो आप या एंगल देख रहे हो आप, दिस इज बेसिकली व्हाट इज जीएमटी, राइट बेटा? मैं यहाँ लिख देता हूँ, ग्रीन
sir.
कलर इज जीएमटी. ओके. अब एलएमटी के लिए लेट्स पिक अप रेड कलर और मैरून. एलएमटी क्या होता है? यू ड्रॉ द इंफीरियर मेरिडियन ऑफ द ऑब्जर्वर.
ग्रीन विच
ये मैंने
ऑब्जर्वर।
ऑब्जर्वर का इंफीरियर मेरिडियन ड्रॉ कर दिया. दिस एंगल इज द लोकल टाइम, इन दिस केस एलएमटी, राइट?
ठीक है सर।
ओके, ये दोनों के दोनों
हाँ
आ
तो
गए.
एल के लिए माइनस कर देंगे।
यस,
एल
अब
के लिए
तुम
माइनस
देखो,
कर
जो ये ईडियम है, हमें पता चल गया कि ये कहाँ से पिक की गई है. ये इसी डायग्राम से पिक की है हमने, कि जब भी लॉन्जिट्यूड वेस्ट होगा, GMT would be best. You can see the green color angle, which is the GMT, is greater, and the maroon color angle, which is the local time or LMT, is smaller.
ठीक है सर।
अब पूरा क्लियर हो गया बेटा?
हाँ सर।
वेरी गुड. और क्या डाउट है बेटा, बताओ.
सर ये क्वेश्चन नंबर 6 में ये दोनों अलग अलग, तो उसको प्लेन सेलिंग से करेंगे सर?
ओके, नंबर
सर
6 पे
इसमें
चले
करंट
जाते हैं.
सिर्फ कंपोजिट वाले ट्रैक पे लगना है या रम लाइन में भी लगना है?
Okay, vessel is to sail from this position to this. If the vessel sails rum line, there is no current. बेटा लिखा तो है rum line, there is no current.
ओके.
And if she sails along a composite track, she gets a 1.5 knots opposing current. So the current is only on the composite track, not on the rum line track. So this will help you in ETA calculation. जब आप रम लाइन पे ETA निकालोगे तो आपकी जो स्पीड है, which is 12 knots, will remain same because there is no current. But composite track पे जब आप अपना ETA निकालोगे, you have 1.5 knot opposing current. So आपकी स्पीड जो है ये 12 minus 1.5, it will remain only 10.5. राइट? सो ये तो करंट का डाउट हो गया. और क्या डाउट था बेटा इसमें?
सर ये पोजीशन अलग अलग है तो सर वहाँ उसके लिए आप प्लेन सेलिंग सर यूज करें तो वो डीएमपी शायद।
ओके, ऑल राइट, समझ गया बेटा मैं तुम्हारा डाउट। बिकॉज अब हमें रंब लाइन डिस्टेंस निकालना है दोनों पोजीशन में। सो रंब लाइन डिस्टेंस के लिए हमारे पास ऑप्शंस अवेलेबल हैं। वन इज plain sailing and another is, which one is the other option available to us beta?
ट्रेवर्स टेबल सर नोरिस।
Yes, not traverse tables. Traverse table तो plain sailing ही है बेटा।
मर्केटर।
वेरी गुड, मर्केटर सेलिंग। सो ये दो ऑप्शन है हमारे पास। सो अब आप मुझे ये बताओ कि प्लेन सेलिंग, मर्केटर सेलिंग, इनके फंडामेंटल्स याद हैं या भूल गए?
सर उसके तो याद है, वो 600 माइल तक होती है ना प्लेन तो।
राइट, प्लेन सेलिंग इज अप टू 600 माइल्स।
मर्केटर वाली तो कर सकते हैं, फिर उसको DMP निकालना
ओके,
पड़ता
ठीक है बेटा। सो बीच बीच में भूल गए हो आप, तो अब हम ऐसा करते हैं
हाँ जी सर,
कि
भूल गए।
नो प्रॉब्लम, मैं आपको ये जो सेलिंग्स है हमारी रंब लाइन सेलिंग्स, इनके बेसिक्स एक बार रिफ्रेश करवा देता हूँ। इसमें सारे फार्मूले भी कवर अप हो जाएंगे, प्लेन सेलिंग के, मर्केटर सेलिंग के। पैरेलल सेलिंग तो हमने ऑलरेडी कर ही ली है, बट नेवरदलेस वी विल कवर इट अप। सो ये तीनों रंब लाइन की जो सेलिंग्स हैं, इनको हम एक बार प्रेजेंटेशन पे डिस्कस कर लेंगे। सो वी विल डू दैट। लेट मी कवर अप द डाउट्स फर्स्ट। डाउट्स क्लोज आउट होने के बाद मैं आपको ये तीनों सेलिंग्स जो है प्रेजेंटेशन में एक्सप्लेन करता हूँ। उसके फार्मूला जो हैं दैट वी विल नोट डाउन एंड दैट विल क्लैरिफाई दिस डाउट इन द माइंड। ओके बेटा, सो जस्ट होल्ड ऑन फॉर द प्रेजेंटेशन। आई विल टेल यू अबाउट द रंब लाइन सेलिंग्स। Any other doubt other than number 6?
सर सीलिंग लैटिट्यूड एंड लिमिटिंग लैटिट्यूड सेम है।
Same beta, both mean the same thing.
ओके सर। एंड सर ये फोर्थ का जो लास्ट पार्ट है, फाइंड द लैटिट्यूड, वो वाला भी सर एक बार कल प्लीज।
Okay. Find the initial course and the distance. Also find the latitude of the point where the great circle cuts the meridian 015 degree west. बेटा this is exactly same जो हमने intermediate position देखा था ना। First calculate the vertex, then from the vertex we can calculate the intermediate position.
ओके सर, ओके अब हो जाएगा।
Okay.
वर्टेक्स का ही नाम था। ओके।
हाँ, so first find out the position of the vertex. Once you get the vertex position, फिर हमने वो PVX triangle जो बनाई थी, पापा वेक्टर एक्सरे, वो PVX triangle में नेपियर रूल अप्लाई करके हम अपनी पोजीशन फाइंड आउट करेंगे।
हाँ, भारत
ओके सर।
भारत भारत
हाँ भाई।
आपने ये चौथा क्वेश्चन का निकाला है, एंगल ए और एंगल बी अभी?
हाँ, एंगल इनिशियल कोर्स और डिस्टेंस निकाल लिया, करेक्ट है आंसर।
एंगल ए 90 से बड़ा आ रहा है ना?
हाँ, 90 से
हाँ।
बड़ा है।
ओके, ठीक है सर। इस क्वेश्चन में सर वो ए से ऑपोजिट साइड बन रही है वर्टेक्स, लाइक बी छोटा आ रहा है और ए बड़ा आ रहा है, तो कोई प्रॉब्लम
ओके,
नहीं है इसमें?
नो प्रॉब्लम बेटा, नो 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 प्रॉब्लम एट ऑल।
ओके, मतलब वर्टेक्स अपने रूट से बाहर जा रहा है, मतलब ए टू बी पे नहीं है, ए से पहले आ रहा है सर।
नॉट एन इशू बेटा, वर्टेक्स आउटसाइड द ट्राइंगल, कोई दिक्कत नहीं है।
ओके ओके।
ओके, सो और कोई डाउट बेटा?
सर एक चार्ट वर्क के क्वेश्चन का डाउट था सर।
बेटा अभी के लिए होल्ड कर लें, लेट्स होल्ड इट। फर्स्ट आई वांट टू कवर अप दीज कपल ऑफ डाउट्स। मैं आपको रंब लाइन सेलिंग की प्रेजेंटेशन कराऊंगा एंड वन मोर थिंग वाज देयर। जस्ट होल्ड ऑन योर चार्ट वर्क डाउट, वी विल टेक इट अप लेटर, ठीक है बेटा?
ठीक है सर, ओके।
ओके ओके, ऑल राइट। नाउ बेटा एक तो मैं ये असाइनमेंट जो है इसके सॉल्यूशंस आपको भेज दूंगा। आई विल पोस्ट इट ऑन द ग्रुप, इफ़ यू वांट आई कैन पोस्ट इट राइट नाउ। एंड दूसरा हम करेंगे रंब लाइन सेलिंग्स। So you want to continue now? It's about 15:20. You want to continue now, or you want to take a break and then go ahead with the Rumline sailings? Because once I start, so it will take about half an hour plus.
नो प्रॉब्लम सर, कर लेते
कंटिन्यू कर लेते
ठीक है बेटा,
कंटिन्यू सर।
कंटिन्यू कर लेते हैं. Then maybe we can leave early then. Okay. ठीक है बेटा, ठीक है. Let's go to the presentation then. Just give me a minute. I'll set up the presentation. This presentation is going to take us into rump line sailings. There are basically three sailings which fall under the rump line sailing topic. That is the parallel sailing, the plain sailing, and the Mercator sailing. So we are going to see all these sailings one by one. We will understand what these sailings are and how can we use these sailings to find out the various parameters or things or values which we require. We will also see the formula connected to all these sailings and how those formula are applied. Now, before we go into these sailings, the first concept to be clarified in the mind is what is a rump line? We call all these three sailings, which we just now saw, parallel sailing, plain sailing, and Mercator sailing, as rump line sailings. So what is a rump line? A rump line is a line which cuts all the meridians at the same angle. So basically, a rump line will appear as a straight line on a Mercator chart. On a Mercator chart, all the meridians are parallel to each other. And since the rump line cuts all the meridians at the same angle, it appears as a straight line on the Mercator chart. It provides us a very easy method to calculate our courses and distances by using different mathematical formulas. So that's why we use these rump line sailings as our usual form of sailing. Unless the distances are very, very large, wherein we switch over to great circle sailing or composite sailing. For all the small handy distances, we use the rump line sailings. Rump line sailings do not give us the shortest distance on the surface of Earth. But what they provide is the simplicity, the ease of calculation, and the speed with which the answers can be obtained. So these are very easy and quick methods to calculate various courses and distances and to prepare our passage plan quickly. So that is the advantage of a rump line sailing. So let us go into these sailings one by one. Now the most basic form of rump line sailing is parallel sailing. Another concept which I would like to strengthen before we go into it is what do we mean by sailing? I have just now discussed with you 5 types of sailings. I will repeat that once again. First 3 were the rhumb line sailings, that is parallel sailing. Number 2, plain sailing. Number 3, Mercator sailing. And the remaining 2 are great circle sailing, that's number 4, and composite sailing, that's number 5. So what are sailings? Go ahead, beta. Any doubt?
अभी शो नहीं हो रहा है ये.
You are not able to see the. Okay, beta, अभी slide blank है. Only parallel sailing is there. Can you see? Can you see parallel sailing on top?
Yes sir. Yes sir.
Right, beta, right. अभी आएगा. अभी we will have the formula now. In the olden days, sailing was used only for ships which used to have sails. So whenever the ship was moving with the help of wind, we used to say that the vessel is sailing. But now the meaning of the word sailing is basically a method, a technique with which we can find out the courses and distances between any 2 points on the surface of Earth. You see, for a navigator, the basic and the most important thing to take the ship from one point to another point on the Earth's surface is that he should be able to prepare a passage plan. Now, for preparing a passage plan, for preparing or charting out a passage from the departure port to the next destination, we need to know the courses and the distances which are to be followed. We don't have any roads in the oceans, so we need to know what is the course which we need to follow and what is the distance which we need to steam. Once we know these 2 things, that is the course to be steered and the distance to be steamed, we are all set to proceed toward our destination. So that is the most basic calculation which a navigator should know. And sailings are basically different techniques with which we can obtain the courses and distances. Whether it is parallel sailing or plain sailing or Mercator sailing, or for that matter, great circle sailing and composite sailing, all these methods, they tell us what are the courses to be steered and what are the distances to be steamed to reach our destination. Now, as I briefly told you, the main difference between rhumb line sailings and great circle sailing, the advantage of rhumb line sailing is its simplicity and ease with which the courses can be calculated. We just need a simple scientific calculator and we should be able to solve for courses and distances. The great circle sailing and composite sailing is complicated compared to the rhumb line sailings. But the advantage of GC sailing and composite sailing is they give us much shorter distances. And this becomes a very, very important point when you are going on a long passage. Say, for example, a transocean passage. So in this presentation, we are going to see the rhumb line forms of sailing, starting off with parallel sailing, then going to plain sailing, and going to Mercator sailing. Now, coming back to the parallel sailing, as you can see clear from its name, we are traveling parallel to something. What is that something? We are moving along the parallel of a latitude, or we are moving parallel to the equator. So whenever the ship is moving parallel to the equator or moving on a parallel of latitude, this form of sailing is known as parallel sailing. Now, in parallel sailing, the course of the ship need not be calculated. Depending upon in which the direction the ship is proceeding, the course will either be 090 if you are moving easterly, or the course will be 270 if you are moving westerly. So the course is very well known as you find the direction towards which you are proceeding. And for calculating the distance, we use the parallel sailing formula. What is the parallel sailing formula? It is departure equal to d long multiplied by cos of m lat. M lat stands for the mean latitude. This formula is used in parallel sailing as well as in the plain sailing. So for parallel sailing, the mean latitude is going to be the same as initial and final latitude. Both latitudes are the same. For plain sailing, when we use this formula, we take a mean of the latitudes of initial and final positions. That is why the term mlat or mean lat. This formula can also be remembered as departure upon d long equal to cos of mlat. So which way you are comfortable with. Now this departure is the east-west distance between the two places on the surface of Earth. So when you are on a parallel sailing, moving along the parallel of a latitude, departure gives you the total distance to be covered. So to find out the distance to be covered, you calculate the departure using the d long. D long is the difference of longitude between the initial position and the final position multiplied by cos of mean lat. So this is the only formula which we have in parallel sailing. As I told you, the course is already known as you know the direction in which you are proceeding. The direction can be immediately judged from your starting position and the destination. Looking at the two longitudes, you will be easily able to find out whether you are moving in the easterly direction or westerly direction. And the distance is found as departure using this formula. So this is the only parallel sailing formula. So parallel sailing is all clear, beta? Calculation of courses and distances.
Yes, sir.
Very good. Let's proceed ahead. Now moving on to the second rum line sailing, that is the plain sailing. So how does the plain sailing gets its name? Now initially when the navigators started moving into the seas long time back in the history, when we started making boats and started venturing out into the sea, we were not having any high-tech instruments to find the courses and the distances. But in those times also, we had the knowledge of trigonometry. Trigonometry is basically the solution of a right-angled plane triangle. So we were aware of how you can calculate the sides, the angles of a right-angled plane triangle. And the sailors used the same knowledge, that is the knowledge of plane trigonometry. There is two branches in trigonometry. One is the plane trigonometry, another is the spherical trigonometry. Plane trigonometry is for calculating on plane surfaces. Spherical trigonometry is for calculating on the surface, curved surface of a sphere. The great circle sailing and composite sailing use the concept of spherical trigonometry. But as I was telling you, in the olden days when navigators ventured into the sea, they wanted to calculate these courses and distances, and they had the knowledge of trigonometry available with them. So what they did was they used the same trigonometry knowledge to calculate the courses and distances between two positions. So how did they do that? They basically made a right-angled triangle, a plane right-angled triangle involving the initial position and the final position, and they solved it using trigonometric ratios. So that's why the name given to this particular type of sailing was plain sailing. Now going into trigonometry, we are aware that there are three different ratios in trigonometry. We have the sine theta, which is equal to perpendicular upon hypotenuse of a right angle triangle. We have the second ratio as cos theta, which is equal to base upon hypotenuse. And we have the third ratio as tangent theta, which is equal to perpendicular upon base. All three referring to the plane right angled triangle. So let us see now, how did we use these three trigonometric ratios, sine theta, cos theta, and tan theta, to calculate our courses and distances at C. Let's assume that the vessel is right now at this particular position. You can see the position on the screen now. Let's mark it as A. This is our initial position or the starting position. Let's assume that the vessel wants to reach at this particular position displayed on the screen now. I'm highlighting it with my laser pointer. So this is our destination position. Let's mark it as B. This is our final position where we want to go. Now our main aim, we know what is our initial position. We know what is our destination. Our main aim here is to find out what course should we steer to arrive at our destination B. And the second thing, what distance should we be steaming to arrive at our destination? Distance is required because you need to fuel up basis that particular distance. You need to have the supplies, fresh water, provisions, food as per that. So these two are the important things which we want to find out. So how do we do that? We basically involve these two positions in making a right angle triangle. How do we make the triangle? Let's see. You can see a right angle triangle being made. Our initial position and final position are the two vertices of this right angle triangle. Now we want to approach our destination position B starting from A. So the arrow shows the direction in which we are proceeding. And this side of the triangle, that is AB side, is basically representing the distance which we need to cover to reach our destination. So this is one of the items which we are required to find out. Now let's name the third vertex of the triangle as C. Now this angle which you see here, this is angle A. This is the angle between true north. You see AC line is pointing towards true north. It's a vertical line, and the direction of true north on our chart is vertically upwards. So AC line represents the true north, and AB line represents the direction in which the ship's head is. So this is the angle between true north and the ship's head. This is basically our course. So let's mark this angle as course. This is the second item which we need to find out. Now, if you take your attention to the vertical side of this particular triangle, that is AC, Alpha Charlie, this vertical side of the triangle on a chart basically represents the difference of latitude, in short known as D-lat. This is the D-lat between our initial position A and our final position B. If you plot these two positions on the Mercator chart and you measure this up and down distance, that is Alpha to Charlie, it will give you, you measure it on the latitude scale, it will give you the D-lat, or it will be equal to the D-lat between the two positions. Now the horizontal side, which you see, the topmost side of the triangle, is the departure between A and B. So if you see on a Mercator chart, It is the east-west distance between these two positions, the starting position A and the destination position B. And this east-west distance between the two positions is known as departure between them. So we have the triangle labeled now. We know all the three sides. We know one of the angles. Now in this triangle, the angle C which you see, angle C highlighted on the diagram now, is a right angle. It's a 90-degree angle, as AC represents a vertical side, Bravo Charlie represents a horizontal side. So we have a right angle triangle here. Now considering this angle as our course, that is angle A as our course, the side AB of the triangle is the hypotenuse. Hypotenuse is the side opposite to the right angle. So side AB is the hypotenuse. Side alpha to Charlie AC, which is connected with this angle, is the base as far as trigonometry is concerned. And the horizontal side, that is Bravo Charlie BC, is the perpendicular. So we have identified the three sides. Distance is the hypotenuse, dlat is the base, and departure is the perpendicular. Now let us apply the three trigonometric ratios to this triangle. Let's first apply the ratio of cos theta. In this case, it will be cos course. Now we know cos theta is equal to base upon hypotenuse. So cos of course becomes the difference of latitude, or the dlat, which is the base, upon distance, which is the hypotenuse. Now this ratio, trigonometric ratio of cos course, gives us our first formula for plane sailing, and that formula is dlat equal to distance cos course. We have just taken the distance to the left hand side. So on one side you have the dlat, on the other side you have distance cos course. So this is the first important formula we have for plane sailing. Dlat equal to distance cos course. Now let's go to the second trigonometric ratio, that is sine theta. In this case, sine of course, it is equal to perpendicular upon hypotenuse. So sine of course is equal to departure, which is the perpendicular, upon hypotenuse, which is the distance. Now this ratio gives us the second formula for plane sailing, that is departure equal to distance sine course. So this is the second important formula for plane sailing, departure equal to distance sine course. Now let's go to the third trigonometric ratio, that is tangent theta. Now in this case, it is tangent course equal to perpendicular upon base. In our case, the perpendicular is the departure and the base is the dlat. So tangent course is equal to departure upon dlat. This is the third important formula which we have for plane sailing. So you see the three trigonometric ratios, cos theta, sine theta, and tangent theta, gave us the three formula which we use for plane sailing. Now these three formulas help us to calculate the course and distance if we know our initial and final positions, the departure position as well as the destination. If it is known, we can easily calculate what is the course and what is the distance. Now it can also be used to find out the position arrived in case a certain course and distance is followed. Let us say we know that we started from position A. We were moving on a certain course. We have a certain distance. We can easily find out with this course and distance what is the position where we are going to arrive. So these are the two most basic simple calculations which can be easily done using these three formula. Now just to give you a lead, if you know the initial position, you know the course and you know the distance. If you apply the first formula, the course is known, the distance is known, you can get the DLAT. If you apply this DLAT to your initial latitude, you will immediately get the final latitude. Now, when you come to the second formula, we have the distance, we have the course. So when we put these values, we can easily calculate the departure. Now, once we have the departure, we can convert it to D long easily by using the parallel sailing formula, which we saw just a little while before. Departure is equal to D long into cos of mlat. So once you convert it into D long, apply it to the longitude of your initial position and you get the final longitude. So a two-step calculation to find the position arrived. In case both the positions are known to us, you can easily find out the course and distance also. If both positions are known, you can calculate the DLAT. The DLAT can be calculated. You can also calculate the D long, which can be converted into departure. With departure and DLAT, you can apply the tan course formula and it will immediately give you the course being followed. Once the course is known, you can go to formula number 1. You can put the course here, you can put the DLAT value here, and you can easily calculate what is the distance between the two positions. So that sums up the plain sailing. Important thing to note here is that the triangle which we have made, this particular triangle, is made for the northeast quadrant. For every different quadrant, we have a different triangle. I'll show you a little while later the triangles for other quadrants also. But this is the one which we use for northeast quadrant. You can see the vessel is moving on a northeasterly track. And important thing to remember here, the course which we use in any of the triangles is the quadrantal course. It will become clear to you when you see the other triangles also. So the course which we use or which we obtain from the formula will always be the quadrantal course, not the three-figure notation course. Beta, any doubts in any of the formula? I hope it is clear now.
All okay, sir.
Yes, sir, clear.
Okay, beta. All right. Shall we continue with it, beta, or you want to have a break in between?
Sir, continue.
Okay.
लंबी
All
break
right.
दे-
ठीक है बेटा, let's continue. Now, as I told you that we have different triangles for different quadrants. Let's see the triangle for other quadrants also. The triangle which we just now saw was this one, that is the triangle for northeast quadrant. This angle was the course, this side was the distance, horizontal side departure, and the vertical side was DLAT. Now, if the ship is moving on a southeasterly course, then the triangle which we follow is this one. This position represents our starting position. This position here represents our destination. This side, the hypotenuse, represents the distance. The vertical side is the DLAT, and the horizontal side at the bottom is the departure. Now, if you look at the course angle, which is this particular angle here, it becomes clear to you that the course which we should be using in this sailing is the quadrantal course. So you see the course or the angle is measured with reference to south direction. This is the angle between the south direction and the ship's head. So this is the quadrantal course, south so many degrees east. Similarly, for southwest quadrant, you see this is the particular triangle. This is our starting position. We are moving in a southwesterly direction. This is our destination position. The horizontal side is the departure and the vertical side is the T-lat. And this particular angle is the quadrantal course. South, so many degrees, west. And this triangle which you see is the triangle for the northwest quadrant. This is our starting position. We are moving in a northwesterly direction. This is our destination. Then the horizontal side is the departure and the vertical side is the T-lat, this angle being the course. Again, quadrantal course, north, so many degrees, west. So these are the 4 different triangles which we use for calculation in plane sailing. Now, one important thing, you can say a limitation of the plane sailing is that this particular form of sailing, though it is very simple and easy using plane trigonometry, it can be used for distances which are less than 600 miles. Now, why is that so? The reason for this is that you see we have used plane trigonometry for calculating our courses and distances. When we are actually moving on the surface of Earth, we are not moving on a plane surface. We know the Earth is a sphere. So the surface of Earth is not a plane 2-dimensional surface. The surface is a curved surface. A 3-dimensional curved surface of the sphere. So when you use plane trigonometry on the curved surface, errors are bound to occur. So in these calculations, errors are bound to occur. However, till the time the distances are small, to be precise, when the distances are less than 600 miles, the errors which are introduced are so small that they can be easily neglected. The resolution, the error is not so great that it is going to affect our sailing, so it can be easily neglected. However, when the distance exceeds 600 miles, the errors become appreciable and we need to consider them. So this sailing is used only for distances less than 600 miles. So for our normal passage planning, when the distances involved are much lesser than 600 miles, we can easily use this plane sailing to calculate the courses and distances. However, when you are going on transocean passages and the distances exceed this amount, then in that case, the plane sailing should not be used. Either we should use the great circle sailing, or if you want to still do rump line sailing with distances greater than 600 miles, we should be using what we call as Mercator sailing. So that is the next form of sailing which we are going to see. Up to here, any doubts, Peter?
No, sir.
No, sir.
Okay, very good. So let's move on now to
सर जस्ट वैसे ही पूछना था सर सर अभी
बोलो।
जैसे हम किसी में कंपोजिट सेलिंग कर रहे हैं उसमें हम ये फॉर्मूला तो वो वाला ही कर रहे हैं ना डिपार्चर अपॉन डी लॉन्ग इक्वल टू कॉज ऑफ लैटिट्यूड
राइट।
तो उसका इसके कुछ डिस्टेंस लेस देन 600 माइल से कुछ नहीं लेना देना सर
ओके बेटा, जो पैरेलल सेलिंग का फॉर्मूला है,
वो तो कोई
departure,
उसका कोई
हाँ,
प्रॉब्लम नहीं
departure upon d long is equal to cos of m lat. It does not have any distance restriction. It can be used for any amount of distance.
ठीक है सर ओके थैंक यू
Okay, restriction is only on plane sailing formulas, sin theta, cos theta, tan theta वाले जो फॉर्मूले हैं, सिर्फ इन्हीं में है बेटा।
ठीक है सर ठीक है
ओके So now we come to the third rump line sailing, that is the Mercator sailing. Why do we have another form of rump line sailing? We have already done that using the plane sailing. I already answered that question. That is because the plane sailing has a limitation. It has a restriction that it can be used only for 600 miles. More than 600 miles, using plane trigonometry on a curved surface, a three-dimensional curved surface of the Earth, introduces appreciable errors which are significant and cannot be neglected anymore. So we use Mercator sailing. Mercator sailing gives us accurate result irrespective of whether the distance is less than 600 miles or greater than 600 miles. Now the second question is, how do we do or solve the question using Mercator sailing? Now to understand it very simply, whenever we use trigonometry, solving a right angle triangle, we have to have the three sides of the triangle measured in the same units. If you are measuring hypotenuse in centimeters, the base and perpendicular should also be measured in centimeters. So that is the basic principle of trigonometry. We cannot change the units. We cannot measure one side in centimeters and another in inches. The ratios will not work. Sin theta, cos theta, tan theta are not going to work that way. So if you remember, in the plane sailing triangle, the units which we used were the latitude scale units. We used the latitude scale units. Let me show you here. Let's consider this is our initial position A. Let's consider this is our final position B. Let's make the plane sailing triangle. This is the plane sailing triangle which we used. The third vertex was named C. This particular angle was the course. This side, the hypotenuse, is the distance side. The vertical side, AC, is the D-lat. And the horizontal side on top, that is B to C, was the departure. Now, if you look carefully, distance is measured as minutes of latitude. 1 minute of latitude is equal to 1 nautical mile. So we measure this side in units of latitude. Coming on to the vertical side, AC, we measure it as D-lat. Now D-lat, or difference of latitude, is also measured in terms of latitude units. The D-lat between two places is the number of times 1 minute of latitude can be placed. The minutes of latitude between the two places, again measured on the latitude scale. The third side which we have was the departure. And you see, again, I told you departure is the actual east-west distance between any two positions. So all distances are measured on the latitude scale. So you see, we measured all the three sides of this triangle in latitude units. Now in Mercator sailing, a simple way to understand it is that we convert from latitude scale to longitude scale. We will measure the sides in the longitude scale. How do we do that? Let me show you the Mercator triangle now. The blue color triangle which you see, bigger than the red one, is the Mercator triangle. And in this triangle, let's name the vertices as D and E. Now the side DE which we have is the D long between our initial and final positions. So you see the D long is measured using the longitude scale or minutes of longitude. So we have not measured it as departure, we have measured the east-west stretch between our initial and final position in the longitude units as D long. Now coming on to the vertical side, the vertical side now becomes AE, Alpha Echo. Now this vertical side, how to measure this side in longitude units? It is measured as what we call DMP, difference of meridional parts. What is this DMP? As is clear from the name, it is the difference of meridional parts between A and B. Meridional part is nothing but 1 minute of longitude. 1 minute of longitude is also known as a meridional part. So Measuring this side in DMP basically tells us how many minutes of longitude can be placed between A and B's latitudes. How many minutes of longitude can be placed between A and B? So this is the meaning of DMP, difference of meridional parts. How many minutes of longitude can be placed between the parallel of our initial position A and the parallel of our final position B? So you see we have measured the side AE, the vertical side, in longitude units. Now coming to the third side of the triangle. Now the third side was distance. Now there is no way that we can measure the distance in longitude scale because the units of distance are fixed. The distance is measured in nautical mile, and 1 nautical mile is fixed as 1 minute of latitude, 1852.3 meters. So there is no way we can measure the distance in longitude scale. So in Mercator sailing, the third side is left unnamed. We neither use this for any calculations, nor it is found out using the Mercator sailing formula. So the third side of the triangle, that is AD, alpha delta, which is the hypotenuse side, is not defined or not mentioned or not used, not calculated in the Mercator sailing triangle. Now, how do we use these two sides to get the accurate course and distance? Now for this, again, we use the trigonometric ratio. The ratio is tangent course. Now in this case, the tangent course will be perpendicular, which is the d long, divided by the base, which is the DMP. So you see the formula here, tangent course equal to d long upon DMP. This is the only formula which we use in Mercator sailing, the only formula. Now one question may arise in your mind that we have calculated the course. If we know the initial position, we know the final position, we can find out the d long between them. We can also find out the DMP between them. Now at this moment, a doubt may be arising how to find the DMP. I will tell you a little later. So we can find the d long and DMP and the course can be obtained. What about the distance? As I said earlier, we have not defined the distance in this triangle, the bigger blue color triangle. So how do we calculate the distance? For calculating the distance, we go back to the plain sailing formula, that is d lat equal to distance cos course. So once the course is calculated using the Mercator formula, the course is input in the plain sailing formula here. We know the d lat between the two positions, initial and final latitude is known, and putting these two values, the distance can be calculated. So the plain sailing formula for d lat is used to calculate the distance. Now, one important thing here, as far as trigonometry is concerned, mathematical calculation is concerned, you could have used the departure formula also. Departure is equal to distance sine course. So you can put the value of departure, you can put the value of course, and the distance would be known. But we do not use that as far as navigation is concerned. Why don't we use that? Because departure as a quantity is not actually present on our chart. What is present on our chart is either the d lat or the d long. So principally, we do not use the departure formula for calculating the distance. So mathematically, that's correct. It will give you correct answers, but fundamentally, always use the the d lat formula for calculating the distance using Mercator sailing. Another doubt which could arise in your mind is that since we have used the plain sailing formula for calculating the distance, how do we attain the accuracy, the required accuracy in this case? Now the accuracy is obtained, you see, the course which has been used here has been calculated using the Mercator formula, not the plain sailing formula. So this course which we have calculated is a more accurate course. Once this is used in this formula, it gives you a more accurate distance. So the error in the course and distance is eliminated, which came because of using plain trigonometry. Another doubt which could arise in your mind is that in this form of sailing also we have used a right angle triangle only, and we have used plain trigonometry here also. So how do we attain the accuracy? The accuracy is basically attained using these DMPs, difference of meridional part. The DMPs account for the curvature of the earth. So when you get the DMP, difference of meridional part, it accounts for the curvature of the earth and brings in the required accuracy. The second way you could understand it from the chart point of view is, you see on a Mercator chart, 1 minute of longitude is a fixed quantity. You go anywhere on the Mercator chart and you measure 1 minute of longitude, it is a fixed dimension, fixed length. The latitude is not so. Depending upon where you are, at the bottom of the chart or at the top of the chart, 1 minute of latitude or 1 degree of latitude will vary in distance. 1 minute of latitude keeps on becoming bigger and bigger as you go away from the equator toward the poles. So 1 minute of latitude is a variable unit on the Mercator chart, whereas 1 minute of longitude is a fixed unit on the Mercator chart. So when you convert to longitude units in Mercator sailing, that gives you the required accuracy. Now to find out how do we obtain the DMP. Before I go to the DMP, beta, any doubts up to here?
No, sir.
Okay, very good. So beta, you have these formulas with you, but if you want, you can note them down in your notebook. They will help you wherever you will be using plain sailing or Mercator sailing. So these highlighted formulas, you can note it down or you can take a screenshot. Done, beta? Done? Shall we move ahead?
Yes, sir.
Okay. The DMP or difference of meridional part is obtained from the Norris table. We have a meridional part table mentioned in the Norris table, nautical tables, and it looks something like this. You have the meridional parts. The degrees are mentioned on top here. You can see the degrees mentioned from 30 to 39, and the minutes are mentioned on the sides vertically downwards, starting from 0 minutes to 59 minutes. So for any degree and minute of latitude, you can see the meridional parts for that particular latitude. So you can find out the meridional parts for your initial latitude and your final latitude. You can find out the difference between them, and that gives you the DMP, difference of meridional parts, to be used in the Mercator sailing. So this completes all the forms of rumbline sailing. We covered up parallel sailing, the simplest form of sailing with a single formula. Then we covered up the plain sailing using plain trigonometry and the units of latitude. And then in the end, we covered the Mercator sailing, again using a plain right angle triangle, plain trigonometry, but with the units of longitude. So all these three giving us the required courses and distances. We can calculate the course and distance between two positions. And if we know our starting position and we know the course and distance being steamed, we can easily obtain the position arrived. These are the two types of basic problems which can be solved with all these forms of sailings. So any doubt beta anywhere in any of the sailings?
नो सर।
ओके वेरी गुड।
जो एक क्वेश्चन था सर वो ये वाले से डीएमपी वाले से होएगा ना?
हाँ yes beta. Now see in great circle sailing or composite sailing, whenever they tell you to calculate the run line distance, now we know that GC sailing and composite sailing is only done when the distances are huge. So wherever GC or composite is being used, we know the distance is going to run into thousands of miles. Now we know that plain sailing has a limitation of 600 miles, so we will not use the plain sailing. We will always use the Mercator sailing whenever run line distance needs to be calculated to compare it with a GC track or a composite track. So always use the Mercator sailing for calculation of run line distances. Don't use plain sailing.
ओके सर। सर ये एग्जाम्स में आते हैं क्वेश्चन?
The basic questions of plain sailing and Mercator sailing?
नहीं सर, ये कंपोजिट में ऐसे कंपेयर करने के लिए, लाइक रन लाइन डिस्टेंस कंपेयर करना है विद जीसी।
राइट बेटा, जितने क्वेश्चन मैंने आपको असाइनमेंट में दिए हैं वो सारे के सारे एग्जाम के क्वेश्चंस ही हैं।
ओके ओके। तो सर नोरिस टेबल लेके जाना पड़ेगा एग्जाम में?
हाँ बिल्कुल लेके जाना पड़ेगा बेटा।
सर अपने पास तो है।
नॉरिस टेबल आपको लेके जाना पड़ेगा। यूजुअली एमएमडी में दे हैव देयर ओन सेट ऑफ नॉरिस टेबल and their own almanacs. So they will tell you to use those only. However, I would recommend कि आप अपना वाला set भी जो है वो साथ में ले जाओ, because sometimes it may happen that the tables with them may run short. So in that case, instead of waiting for somebody else to complete his question and then running after the table, you can request the surveyor to use your own.
सर लेकिन बाकी सारे क्वेश्चन तो नॉर्मल फॉर्मूले से हो गए।
बाकी क्वेश्चन नेविगेशन पेपर में बेटा?
नहीं सर, जो अभी आपने असाइनमेंट भेजी है वो सब तो नॉर्मल से यूज हो गए, उसमें ऐसे कंपेयर का कुछ नहीं हुआ।
बेटा उसमें एक दो क्वेश्चन है ना वेयर दे वांट यू टू कंपेयर द रन लाइन डिस्टेंस विद द जीसी डिस्टेंस।
जीसी डिस्टेंस के साथ?
यस सर।
Just have a look बेटा, there are questions where you will have to compare the run line. अभी एक क्वेश्चन हमने किया था ना जिसमें करंट था।
सर वही वाला, वो तो 6th, हाँ जी वो तो 6th क्वेश्चन। हाँ जी
right, so they told us to calculate the run line distance there ना।
हाँ जी।
So we have to use Mercator sailing there.
Okay.
Okay. Okay बेटा, so all clear about all the sailings? अब याद आ गया?
यस सर।
Okay, all right. So ठीक है बेटा, I will send you the solutions of this assignment. So have a look at the solutions for comparison and complete whatever questions are remaining. So that's all for today's session. So we went continuously non-stop without break. So now you can break off early. And next session, beta, if you are, next session I will tell you about a typical question which comes in composite. So that is one topic which is remaining. So I will cover up that typical question. And once that is done, then we finish off our question number 4. With GC and composite sailing closed out, we finish off question number 4. And once it is done, then we move on to celestial navigation now. So we will go into celestial sphere the PZX triangle, equinoctial system, horizon system, almanac, ये सारी चीज़ें अब जो है इस टॉपिक के कंप्लीट होने के साथ शुरू हो जाएंगी. So that's the way going ahead. Everyone has the almanacs with them. You have nautical almanac with you, beta?
Negative, sir.
Yes, sir.
मंगवा लो
1992 nautical almanac, yes sir.
1992.
92 वाला
हाँ वही वाला बेटा. उसका टाइम आ गया अब. ओके सो अगर नहीं है बेटा तो ऑर्डर इट, गेट इट डिलीवर टू यू. So soft copy is available on the net also, but I don't recommend using soft copy because soft copy use करोगे तो एग्जाम में दिक्कत होगी. So get a hard copy printed or ordered. You can easily get it printed also, beta, not many pages. Okay, so
सर तो ये मेरिडोनियल पार्ट की शीट सर आप अगर आपके पास हो तो सर भेज देंगे प्लीज.
yeah, I have it with me. I'll send it to you. I'll put it on the group.
और सर ये जो अभी आप जोन टाइम टाइम जोन का बोल रहे थे वो भी बता दीजिए फिर.
हाँ सर,
Okay.
जोन टाइम और टाइम जोन, यस सर.
ओके उसके लिए मैं एक काम करता हूँ. आई विल पोस्ट ए 1 page note on the group. Just go through it. That will clarify your time zone and zone time concept.
ओके.
Okay?
यस सर.
और सर सेम इसके बेस पे हमारा यूटीसी और जीएमटी में क्या डिफरेंस होता है?
वो सेम ही है.
As far as navigation is concerned, both are same, beta. Okay, so no difference in between them. UTC, GMT is the same as far as our navigation is concerned.
Okay.
Okay. So shall we call it off for today, beta?
Yes, sir.
Yes, sir.
Okay, all right then. See you tomorrow morning.
Thank you, sir.
Okay, beta. Thank you. Thank you. Bye-bye.